Well, hi everybody, and welcome to my shop for the third video in the series with this radio. And hey, it's quite an education for me. So, in the last video, I was kind of chasing down this apparently weak or low B+, and another phenomenon involving the, well, what I first thought was the on-off switch being bad, and then I thought, well, maybe it's a tube heater kind of going open and closed a bit, and then it went away, so I haven't been able to trace that. But when I start it up now, it's quite cold, so maybe we'll get right back into that. If that starts happening, then we'll have to take advantage of the situation. Now, my B+ readings, okay, I maybe wasn't thinking so hard. So, a couple observations here now. That, you know, I saw this stuff, and for some reason, it just didn't register. First of all, the big capacitor here soldered to the chassis. Okay, I can see the other wire going down into this area. I should have recognized right away what that was, and that's the, we could call it the AC ground to the chassis from the circuit ground or circuit neutral point or circuit bottom or negative, or all kinds of different ways of describing it. But for some reason, when I looked in here, and what I do sometimes with radios is I look in at the capacitor, and I try to see if one of the terminals is grounded to the chassis. And often it's connected to a lug or something like that, and it just takes a moment to look at it and see that. I looked in here, and that's what I thought I saw, but I couldn't have, because that's not what's there. Now when I look again, so I want to thank my good friend Scott for pointing out what kind of should have been obvious to me. So that means I can't be using the chassis as a ground point for taking a DC test, because it's through this capacitor, and that probably explains also the funny drifting voltage readings. So now I did test momentarily with this as the ground, and it's a good spot. Seems to me I didn't see any difference in the voltage, which is really kind of strange now. Now, our perceptions are really not quite what we might want them to be. At least that seems to be my case. And sometimes I kind of see what I want to see. So let's turn on the radio here, just making a quick check of safety. And we'll take a proper B+ reading, and this time what I'll do is I'll clip right on. It's a little awkward in there. See if I can't clip right on there. I don't want to put a short circuit in there. It's a little hairy. Okay, we're on the 150 volt scale over here, and we're going to put power on with the light bulb restrictor in there. You won't be able to see it, it's behind it's out of view of the camera. There we go. Everything's going normal. None of that stuttering going on here. This might go up and start coming down again a little bit. They're starting to come down again. Those are the plate currents beginning to flow. So that certainly is saying, hey, I've got B+. I've got no on-off switch. So there we are. There we see it. So thanks, Scott. You were right. Now, that leaves the next question. How come there's no radio operation here? And it could be antenna problems. That made a nice sound. I got the volume in. This is probably tone here. This looks like the tone control. Well, we can easily have a leaking capacitor driving up a grid voltage here. Very, very easily. So I think what we need to do is check the grids on, not so much on the audio output tube, it seems to be working, but on the for instance the 12BA6 here. Grid is pin 1. 12BE6 grid is pin 1. I think we're all the same. Pin 1. Okay, so that was not the grid. This is the grid here. It's really, really interesting. So there would appear to be no signal reaching that grid. Grid of what? What was that? That's the 12BE6. That's the mixer tube, I think. Yeah, 12BE6. Oh, it's got another grid. Like pin 7. So 12BE6. Not really. Pin, yeah, well, 7 or 6. G2, G3, G4, G5. What? Yeah. But it can't be that. So it's going to be G7. G3 rather, on pin 7. That's what I'm going to go with. I don't see any positive voltage there. Well, check this one. Pin number 1. Seems quite fine. That's the 50 C5 there, output tube. Oh, there's the other one hidden up in here. Poor antenna. There's really no antenna, it's broken here. I know it was quite a while ago, the wire's actually not connected. Okay, maybe this radio's working and I'm just not hearing it. Maybe all it's looking for is an alignment at this point. So let's push some signals into it. Start the alignment process and just do something nice and crude here. What's happening here? I was touching absolutely nothing. Okay, that was interesting. Was that something giving up the ghost there? It seems to have gone quiet. No, I'd say it's not gone quiet. I don't really know what all that crackling was. Okay, now back to what we're trying to do, which is feed in a signal. Now we'll do this in accordance to the instructions. 12 BA6 control grid. 12 BA6 control grid. Okay. 12 BA6 is. BA6 is this one here. No, it can't be. Flip it upside down here. So BA6 is that one. BE, BA, and then the AT is over here. So on the 12 BA onto the control grid. A little bit tricky to get at. And we got to dial up 455 here. Well, it's working. Let's connect the ground here. Instrument ground. There we go. Hey, we lost everything. Just a second here. Very weak. Now, let's see, this thing says it's a little off, as you can see what's happening here. Okay, I had to go out and shovel my driveway since there's a pretty strong snowstorm going on outside, and I don't want it to build up too high because I'm going out later in the car. So isn't that strong? I'm suspicious of something here. 50C5, 2 or 5. What's this meter here? This guy. This is the 12AT6 1. No. What I'm looking for are DC voltages on the grid. Of course, it's plenty loud now. Yeah. I don't think it was that loud before. Okay, so that's on a frequency of 448, not 455, which is what it should be. And the coil, there's that static. It's a noisy clip lead, that's what I think. Okay, so now, so much for what I thought. Something not too good there. Okay. Another little project for me to do. Hopefully we can just carry on and kind of ignore it. Second IF transformer. Oh my gosh, listen to it. What the heck is doing that? Sounds like a kind of capacitor failure that happens in IFs that have the capacitor IF transformers that have the capacitor inherent in the plastic form of the capacitor, and I think that's exactly what we've got here. And over there, I think. Schematic. It'll probably be these two capacitors. They're actually kind of built into the IF, and they typically have this lightning sort of crashing sound, which is what we hear. Well, let's carry on though. Right, so we're doing the L14 and L13 top and bottom of the second IF transformer. The second IF transformer is '13 and 14. It's the central one here. I'm not sure what's inside there. Does it say? No, I don't think it's going to say anywhere. You know what? It makes it look like a screwdriver type. Yep. There it goes. Oh yeah. Now, we want to take this up to 455. Okay. That's that one. Why don't we put on a, let's put on a proper meter. Instead of just relying on my ears. Okay. I think we have it connected now. I really do need to put duller lights in there. Yeah, you're going to have to trust me on this one a little bit. Okay. Now we're There we are. Now to lug number 5 of switch number 1. Section 3. Lug number 5 of switch number 1. Where is lug number 5? Lug number 5 on switch number 1. Okay, how about show me switch number 1. Studying this diagram here. And if I force down my camera, you can now see the meter. Okay. This is shortwave number 2 oscillator. Is that what it actually says? No, it's got to be switch 1. Okay, switch 1. I'm not finding it there. Switch 1. Switch 1. Switch 1. Probably the multi-section wafer switch. And do you think they're going to label it here? There we are, switch 1, section number 2. What are they showing us here? Wow, this is I love these switches. Here it is here. Switch 1, section number 2. Here it is here, switch 1, section number 3. And over here is probably a switch 1, section number 1. And they have it depicted here as a, you picture it like a sliding switch. And I guess a rotating switch really is kind of like a sliding switch. It's just, you know, if you straighten it out, it would maybe look like this. I'd have to study this to understand it fully for quite a while. But let's see if we can just identify where they're talking about. First of all, it's on switch 1, section 3. So section number 3, hey, it says there rear. Rear. It says rear there too. Okay, it says rear side of. That's the rear. Is there a front? I don't see a front. Okay. Can't do much with the rear here. Section number 3. This is probably it here. Lug number 5. 5. That's 5. What the heck are they showing there? Oh yeah, okay, well, I don't really know what are they talking about. They're trying to get the signal in to grid 7, pin 7, grid 2 on the 12BE6. So why don't we just go there? Well, I say, why don't we just go there? 12BE6 is up there, pin number 7 is that. Right near where I am now. So here we go. Take this out of here and put it on there. Good. Yeah. First I will twiddle it, and then I will. And there it is. All that crazy noise. Just do the other IF transformer top and bottom. There we go. Watching my meter over here. Oh, wait a second. What was that, eh? Holy smokes. That's pretty wild. Where to go? Wow. Something is going quite wonky here. Okay, on 50C5, 2, and 5. Now we got a positive voltage there. You can see it here. Still positive. Wow, what is going on? I thought I saw that float positive. There it goes. There it goes. Okay, zeros. I took it off 0. looking at the grid. On the 12BE6, grid 2. Look at it, there it goes, there it goes. Okay, so I think we got a leaky capacitor connected to this grid. So let's see what we were doing there. Double check it. 12BE6 is on 7. That capacitor right there, C7. 470 picofarad. Or 470 picofarad. And it's coming after the resistor R1, which is a 47 ohm resistor. There it is right there. And this capacitor is is it also connected? One side's connected to the switch, and yes it is. The other side shouldn't be. Oh, well I bet you that's an unused lug on the switch, which is this what makes these things so difficult to trace. At least I find it really difficult. So they're using an unused lug. So that's the capacitor right there. Right there. Okay, so I was monitoring the voltage on this terminal. We saw it swing positive. The capacitor which is blocking it is right here. That guy right there. That little teeny guy there. He's got to come out. And we got to put in a new one. So that's what we'll be doing next.